Thank you so much for organizing MSI and Morton. I'm at home as long as I can remember. I was involved with MSI, so the combination is really good. Thank you. And so today, I love it because all the previous speakers sort of set the talk for me. Now I can just go home. So Hortense has talked about interpretability. Ryan then talked about VAE. And then Jessica talked about this exploration of product space. And this is a method built just to do that. So I'm going to talk about what we call InnoVAE, Generative AI for Patents, Innovation, and Firms. You can actually get the paper here, tiny.cc/InnoVAE. This is a joint work with my doctoral student, and also Sunny Tambe here, professor here at InnoVAE. So before I go, I'm sure everybody now knows generative AI. So we are it's a model that it models data generated in process, so it can generate things, right? As opposed to discriminative model that models probability of y label given x. Generative model actually just estimates the probability of x or joint distribution probability of y and x. So here's a generative AI's powerful capability. What I think is one of the most powerful capabilities of generative AI, other than producing realistic things, is the following. It first learns to generate complex object space. A complex object, it could be image, documents, patent, jobs, portfolios, consumers, digital twin of anything, or products. Right? And in doing so, it learns the object space on composition and scale. Given enough data and high resolution, high quality data. Right? And the trained model then can, one, map up the object space, and thus providing a deeper insights by enabling comparing and contrasting between these objects, and augment purposeful synthesis of new and creative object. Right? It could be any of those multimodal complex objects. And do 1 and 2 at an incredible scale and speed, where the power comes from. I just wanted to briefly talk about how current generative AI may be lacking due to a point. And so anything there is a high quality data, we can assume that the generative AI will gobble that up and have a good semblance of knowledge. We're still arguing if it's an actual knowledge or semblance of knowledge. So Polanyi paradox is a paradox that says human knowledge of how the world functions and of our own capabilities are largely beyond explicit understanding, so-called tacit knowledge. So these are not digitized or put it into data. So these kind of things that we haven't really digitized, generative AI do not currently have access to that, right? It can only learn from web or available data that has been digitized. So it's lacking data on senses, muscle memory, high resolution feeling of emotion, anything we cannot explicitly state due to tacit knowledge. When will this overcome? Nobody knows. Right? So having said that, let me go into that. Our research question here is the following. Can AI represent innovation? And how is this useful? So before you can create a creative artifact, you must first learn to represent, right? And then recognize and then create. Right? So we ask this very small sliver of a piece of question. And so what we did is we prototyped what we call InnoVAE, which is Variational AutoEncoder, as Ryan introduced. It's a neural network generative model. It's a variation on a variational autoencoder to estimate disentangled representation of patterns using multimodal data. So representation learning, as Ryan gave you an overview, is just basically mapping real-world object into a vector representation while preserving certain characteristics in the lower dimensional dense representation. On top of that, there is an additional part called disentangling, which is basically a statistical constraint that each dimensions in this vector space are statistically more independent, therefore made more semantically orthogonal, and more understandable, such that the movement within this vector space is now rendered meaningful and understandable, so going back to interpretability. So patents in an interpretable vector space, now if we apply this entangled representation learning to patents data, ideally speaking, we want the patents to be living inside an interpretable vector space where the axis might be factors of innovation. And this is what we prototype. So if we, for example, use it on computing patents, and now it resides in a vector space where axis might be something like security, human-computer interaction, or whatever the data says it is, right? So result and contribution overview is this innovation space, what we call innovation space, the entangled representation space. It enables exploration into patents, innovation factors over time, and firms. Where do these firms situate themselves in an innovation space, and how do they move around over time? So this approach can be used on any business objects. Imagine embedding jobs in a skill space and seeing how the jobs evolve. Imagine situating firms in a strategy space or product space, or products in an attribute space like Jessica mentioned. Right, so here's just a visualization, 3D visualization of innovation space from InnoVAE, so just three-dimensional. Here, so axes are encouraged to be independent and interpretable. Each of these dots represent particular patent. And here the factors, again, distinctly, it's driven to be distinct and data-driven. Similar patents are near each other. And directions are rendered meaningful, which means that we can actually interpret patent B here has increased factor 2 and 3 compared to patent A, which is not possible with other previous visualization and mapping methods like PCA, t-SNE topping models, and even traditional autoencoder, because they don't internalize this constraint about interpretability or orthogonality constraint that gives the power to this synthesis and comparison. On top of that, if now we have these patents in this interpretable vector space, we can actually get a centroid and represent firms in this innovation space. And I'll show you some examples of what we can do with this. And this, for example, is a two-dimensional representation from our data set of just situating these tech companies in two different dimensions. For example, human-computer interface and document processing. And you can compare and contrast, which might be useful for some sort of a business strategy. So this is good and all, but what does good disentangled representation enable researchers or practitioners to ask and enable, right? So here are some broad overview, a list of questions that this innovation space enables you to do. What could you get if you combine patent A and B? Automate combinational creativity. You can let the computer sort through and combine a bunch of different patents and then try to figure out what would you get if you combine A and B and C. And then sort through that. And then, of course, there has to be a human always validating and making a judgment on that. You can also ask how exceptional is a patent with respect to specific technological factor. Is it exceptional? It's not exceptional. Is it more like everything that came before? What innovation factors increase or decrease over time? Right? What might be a factor that you can that's burgeoning, and then you may have to take notice. You can also rank companies in a technological factor X. And I'll show you some of these things that we have done. And if I'm firm A, what innovation do I need to boost up to be more like firm B? Maybe think about incumbent car companies and then situating, comparing themselves to all the electric companies. Where are they in the technological space? What do we need in order to get there? How do firms move in innovation space over time? And how does that correlate to some performance can be done? What happens to innovation activity in a specific technological region after event X, where event X could be merger and acquisition, things like that. We actually have a spin-off paper based on this too. All right, so the data context, I'm going to just skip the method parts. You can see it in the paper. We used US patent under G06 category, patents and computing system, and the data set included about 240,000 patents between 1980 and 2010. It includes things like PageRank by Google and multi-point touch system by Apple. And these are some examples of innovation factors extracted out by using disentangled representation learning out of patents data. For example, medicine, connectivity, information retrieval, ergonomics, human-computer interaction, security, document processing, automation control, things like that pop out. Now, if you apply this in a different subgroup of patents, entirely new factors will come out, and that's the point. Right? So this is heavily just data-driven. All right, so going back to the first example, synthesis. Well, we can just take the latent representation of the patent and combine them, and then put it into a decoder and let the neural networks just generate what might you get if you just combine this, right? And this is what we did. We have a bunch of examples, but here's what happens if you combine using multiple search engines to search multimedia data patent with a system and methods for rapid updating of credit information. Just maybe think about what might be. I'm just gonna count to 5. Maybe you have some time to think about it. In the innovation space, the closest, we can actually generate that particular point, but we also got the closest actual existing patent, which happened to be a process for protection against fraudulent use of smart card and device for the use of process. We actually did this AMT thing where if the space is regularized, would you be able to guess this? And AMT interpreters were able to do this, replicate this too. So this is what the space is like, what we can do with this space. Given this, we can do patent level exploration. So within the innovation space, we operationalize theory of creativity. So Margaret Bowden, along with Gerard Wiggins, formalized this notion of creativity. And creativity can be thought of as, you can rank creativity within a universe of thoughts or via conceptual space. Conceptual space, by Margaret Bowden's and Gerard Wiggins' definition, for humans, it's a structured way of thoughts or creating creative artifact with framework, rules, and constraints. For example, sonnet follows a particular rule and constraint. Game of Go follows a particular particular constraint. Right? Within this creative artifact, whether it's human or an algorithm, can create a creative artifact. So for machines, it's algorithmically defined representation space, easily understood as embedding vector space. Very similar to what we just seen, right? Embedding, disentangled representation embedding. So within this conceptual space, they categorize 3 different levels of creativity. The first one is the most basic, combinational creativity, which is an obvious combination of extent ideas within a conceptual space. Take A and take B, whatever comes in between. That's a combinational creativity. Any sort of like a VC shots, right? Uber of this, Google of that, Apple of this is a combinational creativity. Then you have an exploratory, which is the next level. It's an exploration into conceptual space beyond simple combination. It's basically instantiating a new point in the innovation space, either to, you know that it could have been instantiated, but never been instantiated. That's exploratory creativity. And then the final frontier and the last most creative ranking is the transformational creativity, which is basically, let's go beyond the boundary of conceptual space. We're going to redefine conceptual space. That's transformative. For example, cubism has been known to be transformative. It's tantamount to sticking out a new orthogonal dimension in the innovation space. Right? So that's a transformative creativity. So then we operationalized this in an innovation space with geometric things like convex hull and things like that. Okay, and then we actually were able to categorize patents into these different things. And there are a lot of papers coming out in the last 3 years about innovation getting less disruptive, ideas are getting hard to find, and things like that. It's actually shown in our result that creative ideas get relatively more scarce. For example, in 1980s, every 3.6 combinational come with 1 exploratory or transformative. By 2010, every 200 for 1 exploratory and transformative, right? And so now with 5 minutes remaining, I'm just going to do some demos of like what we can do. But just the first thing here is we can actually rank companies. Keep in mind that this is only 006 category, 1980 to 2010. Things will differ if you use different data set. For example, for human-computer interaction, Nintendo came up on top as most exceptional, and their prowess of this innovation factor is best of, across all. Followed by Pixar and Emerson, for example, and automation and control, intertrust, Silicon Motion, Toyota came up. Finance and transaction, Visa, CME, and Salesforce. Connectivity, Wells Fargo, Westcorp, Commvault. Turns out Wells Fargo has this patents about document transfers, like they're in the business of mortgage and whatnot, so they're pretty good at this. Document processing, Fuji, NTT, and Dell. Okay. All right, and what we can do here is we can also represent firms in an innovation space, and then put the representation vector into the decoder to just come up with like representative technology of a company. And we did that with big tech companies. Please excuse the broken grammar here. This is like pre-ChatGPT 2020 technology, which is ancient by AI standard. Yeah, it's historical technology. So you can see, for example, Google is a system for transfer fund between a sender and a recipient, includes a sender and a receiver, each of which be associated with a sender, the secure system, and so on and so forth. Microsoft is a portable computer system. It has a screen and a keyboard for use with the computer system, and so on and so forth. Apple comes out to be a method for providing a user interface for a computer system and plurality of computer system. But you can see it's a bit, but it gets the gist of it. Ford is a method for controlling the operation of a motor vehicle. Adobe, a method for control. We have Adobe personnel here, right? So yeah, it's a method for controlling the operation of a printer, which is ancient. Again, this is until 2010. So Samsung is a portable computer, have a housing and a display screen. Sounds like a mobile, right? And lastly, we can also do this. We can compare companies based on their prowess of technological innovation factors. Let's say I'm Apple or Google, and I want to enter into an automotive market. There are a lot of rumors, and maybe they have like these chunk of cash sitting and trying to find if they can acquire some, or maybe do deals, or maybe not even acquire, but strategically partner with some companies. And they might want to find the most complementary partners to work together with, right? So for example, it then tells you what are the factors of technological gap between Google and Toyota, and Apple and Toyota. Automation came up on top for both of them, and manufacture second, but then there's a bit of difference like security and connectivity. Here in Google versus Honda and Apple versus Honda, you can see even the first one is very different. Ergonomics, information retrieval for Google, things like this. So you can see where companies differ. And this innovation space enables that. Since I don't have much time, I'm going to skip this. This is just another thing. If like a Google and Apple, let's say they want to enter into the healthcare market, which I know Apple is doing that. So wrapping it up, companies have been using user-generated data and reviews to design product. And this is an old article decades ago where they were talking about the CNA marketing, which is an entire team of people just reading through reviews and finding demands. And if enough people say, I want certain product, they go ahead and make it. That was their business plan. And they had like 50-something SKUs, 50-something thousand SKUs, right? And now, why not use this technology to embed product in feature space using customer reviews? Product in maybe wish feature space, like customer feedback and complaints. Brand and personality space, using social media data. Assets in risk space, jobs in skill space, firms in business strategy, using 10K, pitch book data, and things like that. So, concluding, InnoVAE is an exploratory tool. The generative AI brings up these possibilities of exploring a new landscape, whatever the complex object that you have a high resolution data on. And with that, thank you.